Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is demultiplexer implementation. The topic is from the unit Combinational Logic Circuit. The subject name is Digital Electronics. In this class we will be seeing two problems of implementation. Either we can say implementation or design of demultiplexer. Let us start the first problem and its solution. The first problem is design 1:8 demultiplexer using 1:4 demultiplexer. So, we have to design using 1:4 means the output for 1:8 will be 8. 1:8 demultiplexer means 1 data line and 8 output lines ranging from Y0 to Y7, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. So, 1 input line and 8 output lines. 8 means 2 to the power 3. So, 3 select lines will be there, S0, S1 and S2. Okay. So, depending on the select line condition, this data line will be transmitted on one of the output line. We are supposed to design this 1:8 using 1:4 demux. So, we need two 1:4 demux. So, we have taken two 1:4 demux, 2 we have taken. So, 1 means 1 data line. So, 1 input, data input is D in. It is coming first to the first demux and is also going to the second demux. Okay. So, 1 input is coming. Now, each is having 4 output lines, Y0, Y1, Y2, Y3. The second demux outputs are Y4, Y5, Y6, Y8. So, what happened? Total 8 output lines are there and 1 input line is there. So, for each demux we will have 4 means 2 to the power 2. So, 2 select lines S1, S0. So, both the select lines of both the demux are connected to a common line B and C. B and C are the common select lines for both the demux. Okay. Because 1:8 demux will have how many select lines? 3 select lines. So, already how many we have done? 1, 2, B and C are 2 select lines and 1 is A. So, it can be used one for enabling this one, and when NOT gate is enabled, the other gate, the first one will be enabled, and connecting to this point it will be the second demux will be enabled. Okay. So, in this way we are able to design 1:8 demux using 2 1:4 demux, 1 input line, 8 output lines and 3 select lines. Now, let us see the second problem. The problem is implement full subtractor using demultiplexer. So, first we need to draw the truth table of full subtractor. Full subtractor, you know, full subtractor is having 3 inputs, W, X and Y. 3 inputs are there and 2 outputs will be there. One will be difference, other will be borrow. So, full subtractor is having 3 inputs and 2 outputs, which is drawn here. 3 inputs W, X, Y and 2 outputs difference and borrow D and B. So, when you are having 3 variables, we can write total 8 possible combinations starting from 000 to 111. How do we write? 000, 001, 010, 011, 100, 101, 110, 111. So, first we have written the inputs from 000 to 111 and we have computed the difference and the borrow columns. We know the binary subtraction. 0 minus 0 is 0. 0 minus 1 is borrow is 1 and difference is 1. 1 minus 0, difference is 1, 1 minus 1, 0. So, this binary operation is used in this truth table. By using that, we have obtained this difference and the borrow column, which we have already seen in the full subtractor class. So, I am avoiding that part. For each combination, how the difference in the borrow is coming. Based on this binary subtraction, you can easily evaluate the difference in the borrow column. So, we got the difference and the borrow. Looking at this difference column, now we can write the list of minterms. The difference column minterms are the function w x y z is having minterms where you are having ones. Here the 1 is at 1, 2, it is 000 is 0, 1, 2, 3, 4, 5, 6 and 7. So, 1 is at 1, 2, 4 and 7. So, we have written 1, 2, 4, 7 and borrow is 1 at 1, 2, 3, 7. So, we have written difference is having 1 at 1, 2, 4, 7 and borrow is having 1 at 1, 2, 3, 7. Now, let us draw the 1:8 demux. 1:8 demux means one input data line, it will be held always 1, D in is equal to 1, 8 output lines starting from y0 to y7, y0, y1, y2, y3, y4, y5, y6, y7. 8 means 2 to the power 3. So, 3 select lines S0, S1, S2, they are connected to the inputs WXY, WXY. Now, coming to these output lines, we need only two variables, difference and borrow. How the difference is coming? By 1, 2, 4, 7. So, the output to y1, y2, y4 and y7. These green lines are connected to get the difference output. And for borrow, we need 1, 2, 3 and 7. Okay. So, these outputs are connected to an OR gate to get the borrow output. So, in this way, using 1:8 demux, we are able to get the difference and borrow. I hope the class is clear to you. If you have any doubts, you can post in the comment section. Thank you. Good luck, students.